Today we're going to walk around some of the features of the DS1000 series of Regal oscilloscopes. In this particular case, we have the 1052E, which is a 2-channel 50 megahertz, 1 gigasample per second digital oscilloscope. First thing we're going to do is go to the probe compensation outputs here, which is going to deliver a 1 kilohertz, 3 volt, approximately 3 volt square wave. And you can see that with the factory defaults, which is where we're starting, we have a lot of well, we're not capturing the signal exactly like we would like. What we do have is a convenient auto run feature, which is going to go out and actually sense both of those, sense the signals on the inputs here, and then it's going to make the best guess for the time scale as well as the vertical scaling for each of those signals. So you see we have multi-signal, single cycle, rising edge, falling edge, and then we can cancel out. So now we're getting the nice square waves. If we want to get rid of the square waves, or we have some kind of issue that we want to get back to factory default settings, that's very straightforward. We just want to press storage, select waveform, and rotate down to factory, and then we can load the factory settings and we'll get back to where we were. And again, if I disconnect the probes, you can see now we're back to DC. I'd like to take a closer look at some of the storage capabilities of the DS1000 series of scopes. I'm going to connect channel 1 and channel 2 to the square wave generator. I'm going to press auto. So now on this display we should see 2 square waves. And now let's say I wanted to store that particular waveform. I hit the storage key, and now I have a storage menu, which I have waveforms, setups, bitmap, CSV, as well as factory, which returns us back to factory defaults. Waveforms are going to be used by the DS series of oscilloscope as well as the DG series of arbitrary waveform generators, and it's stored in such a way that that information can then be reused between oscilloscopes if we wanted to take this waveform image and move it to another scope or move it to an arbitrary waveform generator and then generate that particular waveform. We would want to save it in that particular file format. Setups is going to save the parameters used for our vertical and horizontal positions as well as some of our triggering information. Bitmap is going to be a screenshot of the display, so it's going to have all of the information that's displayed. It would have the menu if we wanted that information. CSV is going to be comma delimited, so we could use that in an Excel or other spreadsheet sort of file in order to do graphing and other analysis. And again, factory is going to return us back to factory defaults. So let's say we wanted waveform, but then we wanted to save that externally. We can insert a USB stick, and now external becomes lit and enabled, and we now have access to the F drive in this case, and we can save that file as a new file. We can also change the name of the file if we'd like using the rotating scroll, and we just hit save, and now you'll see that new file.waveform has shown. We can also then let's load that. So I'm going to hit run. So we're back to triggering, and now I'm going to disconnect channel 1 and channel 2. Now let's load that waveform from the external file. So I hit storage load, or storage external, apologize for that, and now I'm going to hit load on the file of interest. Again, I'll select that new file 0.waveform that we just collected and hit load, and now you'll see that that data, the scope has stopped, and we've also redrawn, let's say, that waveform on the display, and in that way you can transfer waveforms between different areas if you'd like. And let's get back to where we were and take a look. Now let's store it as a bitmap. So bitmap, external. We also have another a bunch of things we can do inverted because sometimes it's difficult to see the black background. We can then invert, and it will change that black background to white. It also inverts the colors of the 2 waveforms, or the 2 traces. And you can choose to save the parameters as a text file or not. Let's do external, and we'll do a new file as well, and save. With a bitmap, it's very useful outside of the oscilloscope, but we can't really load that information in to be used with the oscilloscope. So I hope you found some of those storage features to be helpful. Starting from those factory defaults is always a good idea, especially when you get into some trouble on some of the settings. So we're going to reconnect here, and we'll get back into auto. Okay, should be all set. Now let's look at the sampling and memory features that we have available with this particular scope. We're going to shut down channel 2, and we're going to increase the time scale here we're going to bring it to 50 milliseconds per time division. Now remember, we have a 1 kilohertz signal, so we're looking at a period of about 1 millisecond. So at 50 milliseconds per division times 12 divisions, we're actually looking at quite a number of waveforms. And there, with this particular scope, it's actually very straightforward to zoom into a particular area. Press the horizontal key, and we'll get this zoom window. Now you can see down below, this is the zoomed window that is shown by the open area, boxed in by the blue. So we can start to zoom in, and you'll notice that the window is starting to shrink, and we're starting to see more of the waveform. And so let's go down, and so you can see now we have our square wave, or we can at least make that out. And so now you can see there aren't a lot of sampling points here. But we're acquiring in the normal mode about 16,000 points per waveform. So what we can do now is actually go to the long memory mode, another feature of this particular model of scope. The Ds and the E series both have long memory. Go to acquire, and we go to normal memory depth. And we're actually going to go to long memory, and you can see now it's filled in quite a bit. So let's go back to normal. As you can see, we don't have very much resolution in normal mode because we're acquiring so many data points over 50 milliseconds. We don't have a lot of resolution. With this particular scope series, we can actually go to long memory. That's going to give us 1,000,000 points, and you can see it fills in that very, very nicely. And we can change that resolution of the zoom window, and so you can see that very small slice. It can be very useful for troubleshooting longer signals, and we want to zoom in on a particular area that may be problematic. Now we're going to show how we can use alternate triggering to make a 2-channel scope operate independently. So in this particular case, we're just running our zoom again. Let's clear that up. So we'll get rid of the zoom. We'll bring channel 2 back in, and then what we'll do is now in the triggering mode that we're in right now, we're going to go out of auto and go to normal. But we're in edge triggering mode, and we're triggering on channel 1. When you're in edge triggering mode, the time scale is linked to both of the channels. So as we start to change that time scale, you'll see that both waveforms are changing appropriately, and they're both connected to that same time frame, horizontal time scale. So what we'd like to do is we're actually going to change that from edge to alternate, and what that's going to allow us to do now, you'll see that it'll do a split screen. We're actually going to be able to control them independently. Go to channel 1, we can set a different trigger level, and we can also set a different scale. So we can bring in channel 1, again it shows the different time scale and then the different triggering areas, and we can do the same to channel 2. It can be very useful if you have 2 independent signals coming in and you want to have them on different time scales so you can zoom into different features or different areas of that particular waveform of interest.